Vladimir, and today I will be speaking about integration of mobile test frameworks with Jenkins. So first, something about me. I'm working as a QA engineer in PS Tech in Belgrade. We are developing some Android applications for mobile device management systems. And besides of all the testing of application and writing automated scripts, I am performing and I am maintaining and operate with different kinds of servers such as Jenkins, our local mobile device management system servers, and all the SharePoint servers. So this will be our agenda for today. We will see first the application which will be used for all our tests. And after that, we will cover test frameworks. We will cover 5 of them. Then we will see how we will integrate those with Jenkins and see some conclusion at the end. So first, application under test, basically simple calculator application with some basic operations, so everybody is familiar with that, so you know what are we going to talk about. So test frameworks. First, we will cover 3 sections about these frameworks. We will check something about framework, we will see how the source code looks like, and after that we will see how the project structure should look like in order to successfully start the tests. This is our 5 test frameworks that we will cover today: Espresso, Robotium, UI Automator, Calabash, and Appium. So let's start with Espresso. Espresso is the latest framework provided by Google. It is available through Android support repository, which can be installed with the SDK manager. Espresso is very small API with a Hemcrest matcher library, and it's very easy to write the code because it looks like like English. And it is very powerful for running fast UI tests because you don't need to have any kind of sleeps. Tests start running as soon as application become idle. So here how the source code looks like. So on the first look you see English here. We are on view with some specific ID. We want to perform click action. So basically this test just calculating addition of these 2 numbers 6 and 2, and at the end we want to check if the result in the display view is actually matches the number 8 in this case. Project structure. Basically this is one simple Android application. You have app module. Inside of that you have main folder for our main application, and you have Android test for our test classes. What's the most important thing here is this application ID. You must have this test at the end for all your tests. And Espresso I just use here in order to organize my test. Basically you can remove it, but if you have too many test classes, then you want to order on some way, and in this case I just use Espresso. So moving to Robotium. Robotium is Android test automation framework that has full support for native, hybrid application and also the mobile web. It is open source library with very active community, which means that you have new releases almost once per month. It is very powerful automatic black box UI test that you can write using for Android applications. It handles multiple Android activities automatically, so you don't want to worry about those. And it has its own recorder, so you can record some very complex test cases with only a few minutes and you have everything set up. Here's the source code. Everything is done by this solo library. And difference from the Espresso is because you have little opposite logic. So first you want to click on view, and after that you are finding it by its ID. The test is the same. We are calculating addition of the 6 and 2, and we will check the result using a cert equal function. Project structure, also Android project, and it's very similar to Espresso. In my case, I only change the Robotium folder at the end in the Android test folder. Moving to UI Automator. So it is also the framework that is provided by Google. It is used for testing the native Android application across all devices. His disadvantages maybe because it supports only for AP level equal and greater than 18. Also runs JUnit test cases with special privileges, which means you can span across different processes on device. And advantage of this framework is because you can execute the test on a multiple device at the same time. This is how the source code look like. So first we will have this predefined string for our application ID. And we want to find the object on device by selecting it using UI selector, and we find a specific element with its ID, we want to click on it. And similar for the check results, we are using assert equal function. Project structure, also the same because it's Android project. It is all the tests are located in Android test folder, and just the UI Automator test package is used at the end. Moving to Calabash. Calabash has support for Android and iOS native applications, and also for mobile web. It uses all the tests are written using Cucumber. Cucumber has about 80 different natural language commands, which actually means you're defining on English language when I press the button 6 and when I press the button 2, I can see the result in our display, which is 62. Of course, if you want, you can create your own commands and you can implement it using Ruby. What is the difference on these previous three frameworks is because you're having the test server and you are having the device. So first of all, Calabash will install a test server as an instrumentation package on the device, which listens commands from Calabash server, main Calabash server. All the tests are executed on the server side, and the Ruby client library transfers all the Cucumber commands in method calls and send them via HTTP protocol to the instrumentation test server, which is located on device. Source code. As you can see, there is no programming language. If you want to transfer it to some object-oriented programming language, this feature will be our class, scenario will be our test method, and this, when I press button 6, add, and much more is actually our test steps we want to use. You will notice here that I said earlier that it is about 80 different natural language commands, but this is not one of them. I write it manually, so now we will see how this code really looks like. So I have these two functions, press button and check result. In the first press button function, if you on the first look, you will see hieroglyphics, but actually it's not really difficult. It is one regular expression, and you can see here that what you have inside those codes and pipelines, it is forwarded to this button variable. And after that, we are creating another variable, and we are querying all the buttons with ID provided from here. And after that, when we find it, we want to touch or click on this button. Very similar is for the check result, only we will see if this expected result is same as actual result, and if it's not, then we will throw error message. This is one additional file called Calabash settings. This file has information about key store location on our machine. Here we have the location, we have the password, and we have alias for this key store location. So please remember this, we will use it later, and this is really important. Project structure is totally different than previous three frameworks. First of all, in the root of the project, you will have Calabash settings file here and features folder. In the features folder, there is our 4 classes or features that we want to, where we write our code. And you have some subfolder of step definitions where our predefined steps that we implemented by ourselves are located. Moving to Appium. Appium is using Selenium WebDriver for writing the tests. It has support for native Android and iOS application, and also for mobile web. And in specific case for Android, it uses UI Automator for API level greater than equal than 17 and Cell Android for API level lower than 17. For iOS, it uses UI automation, and for mobile web, it uses Selenium driver. His power is because you can write your own scripts in almost any programming language that exists, like Haskell, Go, Clojure, Java, Ruby, Python, whatever you like. Similar to the Calabash, it also has one main test server, and you have device. And first, Appium will install Bootstrap jar as an instrumentation package on device, which contains our UI Automator server and TCP server. After that, all the commands from Selenium scripts are executed on the main Appium server, and Appium server relies those via TCP IP protocol on device. And if the device has AP level lower than 17, it installs also Cell Android server, and those commands using Cell Android will be run as instrumentation JUnit commands. All test verification is also done on the main test server side. Here's how the source code looks like. So basically, the Selenium syntax, we are having driver and we want to find element by its ID. And when we find it, we will click on it, and after executing some steps, we want to see if the result in our display element is, in this case, equal to 8. Project structure. It is basically, you have this test module, which is actually one Java test project, and inside of there you can find all your test classes. So to summarize about these frameworks, so you can see that all 5 test frameworks have support for Android. For iOS, only you use Calabash and Appium. For mobile web, Espresso doesn't support it at all. UI Automator can support only, but if you specifically set X and Y coordinates and clicks. Scripting language is Java for Espresso, Robotium, and UI Automator, Ruby for Calabash, and for Appium almost any. And this is the supported level, API levels for only, this is for Android. So moving to Jenkins integration. Sorry. Here, we will speak first about something about Jenkins itself, and after that we'll have 2 test cases. First test case will be if you have only one test framework in your project, and the second one, if for any reason you need to use multiple frameworks in your project, then we'll cover this section also. So something about Jenkins. Basically, Jenkins is open source tool for continuous integration. This is very powerful tool for automating all your build, test, and deployment processes. For example, after every source code change, you want that everything is done exactly the same way every time. So you will know that your system is always doing everything the same and on the same way, and everything is working as you expected. Jenkins, one of the Jenkins side is its extensibility, because you have more than 1,000 plugins available, and you can customize your Jenkins environment in the way that you like the most. And for example, if you're developing Android applications and you have tests only for Android applications, you will choose only the plugins that you need for supporting Android. For iOS, you will choose also for iOS. But also you have some of the plugins that has no effect for your framework or for your technology that you use. For example, in our project that we use in my job, we have this situation. We have about 15 different kinds of Jenkins jobs, and we want to see the status of these jobs. So if we want to do that, we need to open browser, we need to navigate to Jenkins URL to log into the server, and after that we can see the results. It's okay, but after some time it's really annoying. And in order to do something about that, we want to find one plugin which is called Build Monitor plugin, where you can select all your jobs that you want to monitor and watch, and it is also accessible by one web page. So if you're asking me what is this, the benefit, because you also need to open browser and go to some web page. So we actually bought one smart TV, which has internet connection, and we put it on the wall so everybody can see it all the time. We open this URL on this TV, and everybody can see the result anytime. Additional benefit to this was if somebody broke the build, his name is shown as a possible culprit, and it is one motivation to fix the build as soon as possible. For example, before our bosses come to work. So, we are moving to job configuration page. So, from now to the end of the presentation, we will mostly speak about configuring these jobs in a different way. This page is has some basic configurations. For example, you want to disable this build to not execute if you depend on some other component or some other environment that is currently not working, and you just, in order to not failing your job builds, you disable it. Or, I don't know, you use some custom workspace, which we will see later, or you set some parameters for running the job. But this is the second part of the job configuration, which is more important. First of all, we can define here our source code management, where our code is located on Git or SVN or any other. We can define when our job will be triggered. In this case, you can select none of these functions, and then you can manually start the job, but this is not at the point of this. So you want it to build, for example, after other projects will build. So you have your build process, and when this process is done successfully, you want to start your test process, for example. You can build periodically. For example, you will use this if you have a very large test suite, about, I don't know, 500 test cases, and there you need too much time to execute those tests, and you want to do it by every source code change. You will do it, for example, every evening at 10 o'clock in the evening. Or you can do this pull SCM, which is basically you're checking your server, your source code management about code changes, for example, every 15 minutes. So every 15 minutes, you're pinging your source code management, you see if there is any change, and if there is, then you start your job. Build section and post-build section is two of the most important sections here. First, in the build, you will define all your tests, or your test steps that will be executed every time when you start the job, and these steps must be really precisely defined. As much as precisely it is, then you will have your stable environment. In post-build action, you are doing a lot of things. For example, if the build broke, you send email to the possible culprits. You can archive the artifacts, jars, APK files. You can start another job to start building. You can publish the test results, and much more. So, now we will cover the section where you have only one single framework in your project, which is the simple one. So first, these three frameworks works exactly the same. They are located in Android test folder in its project structure, and first of all, in our build section, we are invoking Gradle script because we are using Gradle for building our project. First of all, we are doing clean and build tasks. Of course, we want to have fresh copy. And after that, we are doing install debug command, which is actually installing our main application on device. After that, we are executing install debug Android test command, which will actually install our test application on device. And with executing connected Android test command, those tests start running on the device, which is connected to our Jenkins machine. So the tests are executed, and we want to see the report and the results. So all these three frameworks uses JUnit for running the tests, and we need some. We will in post-build actions section, as we speak earlier, we will choose publish JUnit test result report option, and it wants from us to set the path to the XML files where our test results are located. These tests are located in this location. Application is actually the module. You have build, output, Android test results, connected, and here we will collect it by asterisk.xml. Why with asterisk? Because depending on the device you use for testing the application, the name of this file will be called differently. So in order to cover all the cases, we will use asterisk.xml, and it will collect all the files that are created for every device. Health report amplification factor is actually allowed percentage of failing tests, which means, in this case, if you set it to 1 and you have 100 test that is executed, if you have the 2 tests that fails, then your build will fail. If you have 0 or 1 test that fails, this job will be successful, it will pass. And here how the test report looks like. And basically we can see the number of tests that are executed totally and by classes, duration of execution also totally and by the classes, and success rate also for all the tests and by classes. You can see that I used the report from Espresso, but trust me, everything is the same for Robotium UI Automator, only this package will be the different, name will be different, and of course duration of the execution. Moving to Calabash. First of all, as in previous, we will do clean and build as a Gradle jobs, Gradle commands, and after that, please remember now this story about Calabash settings file. What are we going to do? We are calling execute shell action with Calabash Android and reassign our path to the APK file. With this reassign, he is going to see where is our key store located and use those parameters to reassign our APK, which is located here. After that, with the same on the similar command, we are running this application and it will start executing our tests on device. Of course, you want to see the test reports. You must define some additional parameters. Here with format parameter, you can define JSON or XML type, and it must be followed with out parameter where you will define where your report will be created, and you give it name with specific JSON extension or HTML. We said that Calabash is using Cucumber, so we will in post-build actions section, we will publish Cucumber result. It is required that for you to give the JSON report path, and we said previously that we set it to be located in features folder, so basically that's it for collecting the test report, and here how it looks like, really fancy. Basically, you can see the steps, test steps of every scenario. You can see all the scenarios, and you can see here for every addition also the scenarios, the steps, either passed or failed, skipped, pending, maybe undefined, missing, duration of the execution, and which is the status of this. Moving to Appium. Appium is a little more complex because we will need to have 2 different jobs, one for server, Appium server, and one for tests. First we will cover the tests, and after that we will see how the server looks like. But basically, if you want to run the test, you must have your server started first, but you will see why am I going to the test first. So, as in previous 4 frameworks, we are going to the Gradle script, cleaning and building our project. After that, we are installing our application on device by install Android application command. And Appium is using testng runner for executing the tests. And we will run it by this way. We will set class path to our libraries that we use in our test and path to our build test classes. After that, we are starting testng runner, and additionally, we can give this test.ng XML file where we have defined all the test classes we want to use. Second command is actually we want to shut down the Appium server. We don't want it to be run all the time. We want to start it, we want to execute tests, and after that we want to shut it down. Appium server is starting as a Node.js process, and with this command we will terminate it. Also, we are sending seek-term signal. You will see later why, because we want to catch this signal on the Appium server job side, and we want to gracefully exit, because when you do kill the all, you are terminating your process by force, and it is providing error message, and we don't want to provide error message because we do it intentionally, and this is something that is expected thing to do. And the final task is to uninstall all the applications that we installed on device. Only for Appium this is done manually. All other frameworks covers this automatically. Here is the look of the test.ng XML file. So basically, simple XML file, we define all the classes you want to run your tests. Test report, post-build action section. We said we are using test.ng runner for running the tests, so we want to publish test.ng results. We are giving the path to our XML file of our tests, and the test looks like this. So basically you can see all the methods that are run, and you can see chronological order in which time it starts executing some special test method. So you will see first up the setup will be done at the beginning, after about 7 seconds first test, and so on and so on. And here is the Appium server job. We are only the test, only build step that we have is this execute shell script, and this is just the location of our script that we created, and we want to exit gracefully after this script is finished. Here how this script looks like. So basically you're starting it with the Node.js process by this way, and you're trying to catch kill all node command with seek-term signal. When you catch it, then this job will start, the server will start executing, and it will be gracefully exit, and you will have the jobs are passed. It won't be red, it will be green. So, multiple frameworks. First of all, what is the problem here? The problem is when you want to, for some reason, run multiple frameworks in your test. For example, you will use Espresso for UI test, and in your application you need to know what is the temperature or of the weather, and you will use UI Automator for it because it has support. You will collect it and pass it to the Espresso, and everything is done. For example. So what's the problem? Espresso, Robotium, and UI Automator are located in Android test folder in the project structure, if you remember. When you execute connected Android test command, it will start executing all the tests in that folder. So in this case, it will start all the tests from all 3 frameworks. For example, you don't want to do that. You want to run only UI test, which is defined by Espresso, and not to run Robotium and UI Automator. You can do it by using ADB command and start instrumentation. But the problem is if you use that, then you cannot see the test results. And of course, we want to see the test results. There is one tool called Spoon that can create these test reports, but if you have too many classes, you have to invest too many time to write this configuration file, and if you have, for example, 50 test classes, this is really too much time to lose. So here is the solution. First, in our build Gradle file, you will create product flavors, which is actually 5 different versions of the same application. All the functionalities is the same, Only the difference is in its application ID. So we'll call it Espresso, and we will just put Espresso as our application ID on the end, and also for all these other frameworks. Project structure is changed also. You will have now 3 Android test folder called by the name we provided in build Gradle in product flavors. And in all of these frameworks, these folders, you will have only the tests of this specific framework. For Calabash and Appium, they are all, you can just put it and you have no problem with it. It's working really good. So, integration. First of all, because this is now one project, we will create build job. And this job will only, when there is some source code change, we will clean everything, we will build it, and that's it. This is only the purpose of that. After that, all other jobs will have these options that I mentioned earlier. Use custom workspace. And we will using the workspace of our calculator build job in order, because all the files we need with APKs and everything else is located there. There is no need to run it again, to build the job again from the beginning. So, Espresso. First of all, we cleared these clean and build tasks because it is done in the calculator build job. And after that, actually everything is the same, but the command name is different. First, install Espresso debug will install the main application to device, but it is Espresso version. So Espresso version of main application will be installed to device. Then Espresso version of Android test version will be installed to device. And after that, connected Android test Espresso debug will be start actually the running Espresso version of the test and for the main application. Very similar for the Robotium, the commands only is different. Robotium will be used for all the three commands, and also very similarly for UI Automator, you are guessing. Test reports will be a little different because we have only the location will be different. The first thing is the same to the connected side. And after that, because you're using flavors, we want to know for which flavor we created some test report. And you use flavor and then Espresso or Robotium or your Automator, and there will be our XML files. Calabash, we are removing clean and build commands also. And in this execute shell script, there is only one difference. The name of our APK is different because we will have this Calabash version of our application instead of just without it. And it's similar for it is the same for the resign and the run commands. Appium, also removing clean and build from the Gradle. The application that we are going to install is the Appium version of the application, starting TestNG runner on the very same way, shutting down the server, uninstalling all the applications that are installed, and that's it. So, let's see some results. This is the table with time execution of the tests and complete Jenkins job. You can see for the Espresso that tests are done the fastest, which we expected because we said there is no way it starts immediately as soon as the application is idle. And job is also the fastest because of that. Calabash is the second in this race. He executes tests really, really fast, but entire job is taking too long because of this server that he used. Robotium is the third one, and the ratio between the test and the job is pretty much, you're not losing too many time for some steps or events outside of tests itself. And you can see that your Automator and Appium is taking too long and for the test and for the jobs. But when will you choose these frameworks? For UI tests, Espresso is your #1 option. If you want to use some native applications, let's say widgets, when you can get this temperature, you will use UI Automator. If you need to write very complex tests, use Robotium and use its recorder, just click it, record it, and everything is written. Calabash and Appium is good only if you want to use the same framework for both Android and iOS applications. That's why I would do it in that way. So, what we covered today, we will see the test frameworks and what is the difference for those. We will see how to integrate it with Jenkins if you have only one single framework in your project and if you have multiple frameworks in your project. And we covered the time execution for all these frameworks on Jenkins. What should be the next steps? First of all, you can create some build pipeline, which is actually, you have this build job, and after build job is executed, then you transfer it and start doing some tests. You have, I don't know, 1, 2, 3, 5 different kind of test jobs, and after all those are executed and every job is successful, you can deploy it to the production system, for example. This concept is also known as continuous delivery, and more about continuous delivery for mobile applications you can see on this link, and also this is the links for every test framework that we covered today, so you can see more information, how to run the tests, how to write the tests, and much, much more. So, thanks for your attention. Do you have any questions? Yes? Yes, you just connect your device with a USB cable to the machine that runs Jenkins, and it will be started. You just need to run the Android server. Their ADB server must be run from the root privileges, and after that, when the device is shown by ADB device command as you should, then everything will start it automatically. It can see it everything perfectly. Yes, yes. You can also define on which device you want to test, but if you have more device, he will start doing on every device. Next. Yes. Well, basically, because all the tests are done on the device, if your device is by accident really near to you and you start your tests and I don't know, you move some cable and this cable press on the screen, you can see the false negatives because, for example, you're trying to calculate addition of the 6 and 2, and in this process you actually click on one other button and then the result won't be the expected one. But you can check it, what's really happened. The reports are very good enough to see what's the problem. You can see the expected result, actual result only in this case. But basically, you must, if you are using the automating running test on real devices, try that to be separate, that you don't have ability to touch it. Otherwise, maybe you have some false negative. Yes? Yes. Yes, if you remember this job configuration page, when we spoke about source code management and build steps, there is one option to run Android emulator. And when the build starts, you can run an emulator in the background and you can start it. Of course, you must have environment, GUI environment. You cannot run it on the virtual machine that has only the command line. You must have the real environment. Yes? Yes, Calabash and Appium can do that. Well, actually, I didn't try it for iOS because I'm working only with Android, but uh, I really don't know how it's worked for iOS. I really don't know. I know that it has support, but I believe it's really simple to implement. Only the writing the scripts are maybe the difficult one, but integrating with this is actually... Well, we use Android commands here. Install Android package. Maybe you will have installed iOS package, and after that you can start testing it. Well, I didn't have the experience with iOS, but I don't know, find me later and maybe we can see what have you done and what should be done. No problem. More questions? Okay, that's it. Thank you all you guys for coming.